Yeah, I was a postdoctoral fellow at Harvard Medical School in Boston, and I was studying enzymes that are involved in synthesizing cell walls in bacteria. And quite honestly, I had no idea that I was doing something that might be useful. I was just really, fascinated with how bacteria built their own cell walls. But that was a time in the early 90s where drug resistance was beginning to kind of rear its head in the clinic. And I became aware then that the work I was doing was, may have some practical utility in the way of, discovering new antibiotics. The fundamental problem that surrounds drug resistance is that the existing drugs are really just tweaks on existing chemical classes. And so there's been a real lack of innovation in antibiotic drug discovery. The most recent discovery of a new chemical class of antibiotics was actually in the 80s. So quite remarkable that there's been so little innovation in that time. Where in my group we're trying to think about completely new ways of discovering antibiotics. Much of the effort that's happened really over the last 30 years or so has been rooted in fairly reductionist industrial approaches to drug discovery, which are in the modern era. Which involve, genomics to discover what's the right target, recombinant DNA technology to express and purify a target, large chemical libraries over that target, and then, medicinal chemistry, right, to make that compound better. I think what's at issue there is maybe a fundamental lack of understanding of the system as a whole before, those reductionist approaches are commenced. And so a lot of what we do is just truly to try to understand the bug as a system, and also really to think about studying the whole organism in the context of drug discovery, and then kind of letting the bugs tell us what will work best. The solution, certainly, to the drug resistance problem is just in part new antibiotic drug discovery. There needs to be stewardship measures, to reduce the use of antibiotics, and we need to be really mindful, I think, about the way that we treat disease. But there is always going to be a need for antibiotics, and I think that if you think about straightforward surgeries and things that we just take for granted, things like hip replacements and cancer chemotherapy, etc., all of these are interventions that just require antibiotics. It's hard for me to imagine a world where antibiotics aren't necessary, where we're maybe so careful about infection, and we're so good at stewardship that we no longer need antibiotics. I just think they're here to stay, and let's hope they're still useful far into the future. Yeah, this is a really fun project in my lab. It was we've been working in MRSA cell wall synthesis for many years, I dare say about 20 years, and interested in a particular pathway. We ran a screen for chemicals that would interfere with the synthesis of that aspect of cell wall synthesis, knowing that there might be sort of interacting pathways. This kind of gets back to my obsession with the system as a whole, and how cells are really complex in the way they respond. And it turned out we identified a compound that hit a pathway that was interacting but quite separate from our sort of starting hypothesis. and that was a gene product that was involved in helping cells respond to an assault on cell surface and cell wall. And it turns out that this target, had a lot of really interesting effects, phenotypes for the bacterium. It made it difficult for the organism to make a biofilm. It slowed its growth. It halted its virulence in a worm model of infection, and it reversed drug resistance. So it's kind of like this thing was a Swiss Army knife of targets, if you will. And sort of all kinds of really interesting consequences to the inhibition of this target ensued when we found this compound. All drugs are paid for on a sort of per prescription basis. In other words, they're paid for in terms of volume of use. And if you think about it, that's exactly the wrong thing for an antibiotic. We really want to discourage high volumes of use of antibiotics because we know that with use comes resistance. So stewardship demands that we use as little of a drug as possible. On the business side, that's the worst possible thing for a pharmaceutical company is to come up with a drug that use will be restricted. And if you think about it, a designer new antibiotic that's really effective and could save a patient's life, say in the ICU, is one which will see a very low volume of use. It'll be used as a last resort. And so one of the biggest obstacles is how then to incent pharmaceutical companies to discover and develop drugs like these. And there are a lot of interesting proposals before legislators and thought leaders about how to incent this industry. And I mean, some of the most interesting ones involve decoupling volume from value. And that would be a first, right, to pay for the value of a drug and not the volume of a drug. It's a really interesting problem. We've seen a significant departure of pharmaceutical effort in this area. So the research intensity of a pharmaceutical company is, really correlated to return on investment for its shareholders. And so that's a big concern, right? It really hampers, I think, our ability to deal with this. And I think it is a very significant part of the lack of innovation over the last, several decades in this research area. So that concerns me a lot. What gives me a lot of hope is I think there's kind of been no time, at least in my career, where there's been a greater understanding of that problem. And so I think we're seeing a lot of discussion among legislators, a lot of concern among governments and non-governmental organizations worldwide. And if that can be translated into action, I think we'll be in good shape. But it is a difficult problem to tackle. It'll require multinational cooperation. Microbiology in general is kind of amazing because it's in us, it's all around us. We kind of ignore it, right? But there are more bacterial cells in and onto human than there are human cells. And increasingly, we're recognizing how important that is and what the role of microbial physiology is in human physiology.